Okay, so very first thing with right triangle trig, we're going to go back to, I think y'all said y'all remember this from last year. Y'all remember doing SOHCAHTOA? Hopefully. Okay, and what, if you do or don't remember what SOHCAHTOA is, the S in SOHCAHTOA, that's the sign part we were talking about. And if we drew a right triangle,
These notes you gotta take down?
if you do or don't remember for sign, that basically if you stand in a corner here, you had to go back in and label all the sides for everything that was here. The one thing that's always the same in any right triangle, now you know if it's a right triangle, if you've got this little corner here, is that if you drew an arrow through this box, this would always be the hypotenuse. Trig, T-R-I-G. Okay. All right. The other thing you had to kind of get was if whatever angle they gave to you, if you were standing in this corner, and if you don't get this today, let me know. We'll actually go tape this up in the hallway so you can kind of get everything that's going on for this part of it. Is that if you stand in this, if you shade it in this corner that this angle is in, the other side, because one side's always going to be the hypotenuse. The other side that you're shading in is going to be what they call the adjacent side. Yeah. So if you were actually standing in this corner, if we had like a rope set up where we had a rope triangle, if you stood in this corner and you could put your hands on these two sides, one side will be the hypotenuse and one side will be the adjacent. The one side you're not touching, which is over here, that's going to be the opposite side. Okay. So when we talk about sine and cosine and tangent, all of the things here, sine is going to be the opposite over the hypotenuse. Cosine is the adjacent over the hypotenuse. Just going to write them down. Y'all can get them here in a second. And then tangent is opposite over the adjacent. Okay. So that's where we got the SOHCAHTOA, where if you take the first letter, S-O-H, C-A-H, and T-O-A, that's where we got the SOHCAHTOA. All right, now the big thing to kind of remember as you're doing this one is if we took this same triangle ahead and we redrew it, and instead of X being in this corner, if you put, let's just say we did Y up here. So exact same triangle, but now instead of talking about angle X, maybe now we're talking about angle Y. That the one thing that's still the same is the hypotenuse. Because again, if you draw the arrow through the right angle, it's still going to point to the hypotenuse. Okay, but now if you're standing in this corner, the other corner that you're standing in, basically now this side becomes the adjacent. And then the side that's farthest away from you over here that you're not touching, this side becomes the opposite. So depending on what corner you're standing in is going to change which side's opposite and just which side's adjacent. Just like if I'm standing on this wall, the opposite wall is over there, right? If I go stand over there, now where's the opposite wall? Over there. So which corner you stand in is the difference of which one's going to be the opposite. So if you're standing over here, that's the opposite corner. If you're standing over there, that's the opposite corner. So you always have to look at which corner you're standing in to know which one's going to be the opposite and which one's going to be the adjacent as you go through those. Okay. All right, so what they're going to ask you to do. Okay, so what we're going to ask you to do in this case is they're going to ask you, basically you're going to start off with a triangle. And they're going to ask you to write out the trig ratios. Okay, and they should give you a triangle with different measurements on it. So it's 5, 12, and 13. Okay, and they should ask you to find sine of x, cosine x, tangent x. And again, we got to tell you which one's x. So we'll put x in this corner over here. Okay, and as soon as you get in that corner, again, you go back in and label the things that you know. The one thing that never changes is the hypotenuse, which is your longest side. Again, it's always, if you drew an arrow through the right angle, it will always point to the hypotenuse every single time. That's the one thing that never changes. If they ask you to find, talking about x now, again, if we're talking about x being in this corner, then the side that's opposite would be over here. So that's going to be the opposite. And then that's the 5 here, since it's the other corner part with us, that means that's going to be the adjacent. Okay, now the part I'm going to put in pencil, you don't have to write this down, but this is just kind of thinking what you're going to do. Sine, we said, was it's SOH, so its sine is opposite over hypotenuse. So we need the opposite over the hypotenuse, which for that one, and here's the final answer we're going to do, is 12 over 13. Slide put up here. So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So that's the A over the H. So that's 5 over 13. And then the total part tangent is the opposite over the adjacent. So that's 12 over 5. Okay, so if they give you the numbers and just ask you to write the ratios, that's all you have to do. Now, if these numbers, if you can simplify the numbers a little bit, they'll probably make you do that. But most of the time, I doubt that they will. I mean, occasionally they might, but most of the time you'll get numbers like this that you don't have to simplify. Okay, and then a lot of times they'll ask you to find same thing, but now we're going to find sine, cosine, and tangent of y. Okay, now the big thing on that one is that if you change corners, because we were talking about x, now we're talking about y, so now we've got to change these answers, or these sides that we're talking about. So now if we're talking about y, we're not talking about x anymore. Hypotenuse stays the same. That's one thing that always stays the same is the hypotenuse. So now if we're standing in this corner, the other side that helps us draw this corner in, that means this will be the adjacent. And that's going to be the opposite. Okay, so sine is now opposite over hypotenuse, so that means that's going to be 5 over 13. Cosine should be the adjacent over the hypotenuse, so that's 12 over 13. And then tangent is opposite over adjacent, so that's 5 over 12. Okay, as long as I say just write the ratios, that's all that you have to do is just write down what numbers they give to you, and then that's pretty much about it. Okay, now here's where we need to, once everybody's got that written, here's where we need to do some calculator practice. So if you've got your calculator, go ahead and take out your calculator. I'm going to show you how to practice on this one just to make sure everybody understands what's going on. Okay, so a lot of times they're going to give you a problem like this, and they may ask you then to, after you've gone through and done the ratios, they may ask you to then take this triangle we've got, and they may ask you to we're going to find X, and then over here, we're going to find Y. Okay, now don't be the genius on the test that will go over here and circle that and go, found it. No, that's not what that's not what I'm talking about. This is not like Where's Waldo that you're trying to find the X. No, you actually have to tell me how much it's going to be. Okay. Now, if they told you that if this was like 33, we wouldn't need this. But if you have to find the missing angle, here's what we're going to do. This is what you got to use with your calculator. It doesn't matter because if we're going to find X, we're not worried about everything that's over here. We're just finding X right now. You can take any one of these questions that's here and to use your calculator. If you've got it like this where it's like sine of X and you're trying to find the missing angle, what you have to do is you have to hit second, and then we're talking about sines. We're going to do second and sine, and then just put in your two numbers. It's 12 divided by 13. All right, so everybody check and make sure you got 67. Because one thing we'll have to do when we take a test is we got to make sure that if it's in the wrong mode, you won't get the right answer. So we'd have to kind of do that one. So did everybody get 67.3? All right. Anybody not get 67.3? They good? Mackay did?
I didn't. Wait, where's your dog say it?
Okay.
No, I didn't. I didn't have a calculator.
Okay, so we're going to round that thing off and say that's basically just 67. We're going to get rid of the 0.3. And if you round it off instead of putting equals, just put the little squiggles, because the squiggle means that we're rounding that answer off. Okay, now the good thing is, it doesn't matter which one of these three operations that you do. If we had done cosine, you get the exact same answer. If you do second cosine 5 divided by 13, you still get 67.3. If you did second and then tangent of 12 divided by 5, you're still going to get 67.3. So it doesn't matter which one of these. If they give you all three numbers, you get to pick basically which one you want to do, and then you just punch that number in. And again, if the angle is missing, like we've got with the X's and Y's up here, you have to hit your second button first so that you've got this -1 that pops up here when you do this. Okay. All right, if you have to find Y, it's the exact same thing, but now we've just got a different set of numbers. So if we got to find it with this one, we're going to do second and sine, and then do 5 divided by 13. And that comes out to be 22.6. And again, if we round that off, that's about 23. Probably in a lot of the homework problems, they're probably going to tell you to go to at least one decimal place. For this one, we're just going to round this thing off and say it's about 23 degrees. Again, it doesn't matter if you do this one. Doesn't matter if you do the next one and do cosine and do 12 divided by 13. They're all going to come out to be that 22.6. And same thing if you do tangent. You get the same answer there. And again, we're rounding it off to the whole number, so that's why we got 23 instead of 22.6. Okay, so everybody okay with that one? Okay, now here's the other thing you could have done. Remember, if you're doing a right triangle, once you find this angle, if you need to find the angle in the other corner, the other thing you can do is you can just do 90 minus this angle. And that'll also get you that same angle that we're talking about right there. So if you find one angle, you don't have to do it on the next one. You can just do 90 minus this angle, and that'll tell you what that angle would be there. Okay, so let's do this. Let me give you a couple more of those where we're going to find some other different parts and pieces of it. Do a little calculator work, and then got one other thing, actually two things I got to show you here at the end. Okay, for this one, we're not going to do the trig ratios. We're just going to find X. Okay, so there's our triangle. Okay, so here's what you have to do with this one. If you're finding X, which means we're in this corner, you've got to label all your sides based on what you have. Now, the only side you need to label are the ones that actually are showing up. So this side, we're not going to worry about it. So if we're standing in this corner, again, draw through the right angle. So this is the hypotenuse. If you're standing in this corner, this would be the adjacent, but there's nothing here. So for this one, we got to find this side, which means that would be the opposite side. Okay, and then whatever two sides they're given to you, in this case, it's the opposite and the hypotenuse, that lets you know which one of these we're going to use. If it's SOHCAHTOA, you got to go back and find, all right, if we've got opposite and hypotenuse, we're going to use sine. If you've got adjacent hypotenuse, you have to use cosine. If you've got opposite and adjacent, you're using tangent. We've got opposite and hypotenuse marked, so that means we're going to have to use sine for this one. Okay, so in this case, it's the sine of the angle, so we're going to do sine of 33 equals, and then opposite over hypotenuse is x over 14. Okay, so if they give you the angle, this time you don't have to hit the second button. This time you can just take this number you got and you can just hit sine of 33 and get that number. Okay, so if you do sine of 33, that's 0.5446. Okay, and then what you're going to do after that is you're going to do cross products, but the cross product should be really easy because if you multiply these two, you get x. And on this one, we're not going to use our calculator. I mean, you're not going to do it by hand, just use your calculator. Take that same number you've got here and then just multiply by 14. Okay, we're going to round this thing off to one decimal place, so that's like 7.6. Again, this will be inches or feet or miles or whatever it is that they're talking about in that case. Okay, is that okay? Again, why we use sine there? Why we didn't use tangent or cosine? Again, you got to stand in your corner, figure out what sides did they give to me to work with, and whichever sides they give to you to work with, that's one you got to do. They didn't put anything here, so we just don't worry about what that side is. We just need to know what these two sides are. All right, let's give you one more of those. Okay, so this time we're going to find y. Okay, again, you've got to label everything based on what they're giving to you. They're giving us this angle, which is angle y. And again, if you draw through the right angle, this always points to the hypotenuse, so that's the hypotenuse. And since we're standing in this corner, this would be the opposite side, so that 9 has to be the adjacent side. So if you've got the A and the H, means you got to use cosine because that's the CAH part that we got here. So it means we got to go cosine. So we got to go cosine of the angle, which in this case is y, equals adjacent over hypotenuse. And again, depending on what's in this case, the angle is missing. So you can't just punch it straight in. So if they give you the two sides, that's where we're going to have to use our second button. Let's see it here. There we go. So we're going to go second. This time we're going to use cosine, and we're going to do 9 divided by 20. Okay, and it tells us that's about 63.3 if we round that thing off to one decimal place. Okay. And again, some problems will tell you to go to one decimal place. Some of them will tell you to go to the whole number. You just got to read through the question and just see what it's doing. Okay. So again, the big thing is if the angle is missing, you got to use your second button. Okay. Now, one thing that you probably everybody remembers, please. Now, if we get, because some of these questions they may not ask you, they may not even give you an angle in this case. It may just be that they may ask you to do something like this. We're again still finding out one of the missing values here. Okay, no angles. So if they have one like this, if there's no angles, they don't give you any angle. I mean, other than the right angle, we know that. But outside of that, we know this would be the hypotenuse. But they don't give us either one of these two angles, so we don't know if we're supposed to be in this corner or this corner. So if they don't give you an angle at all, then basically you've got to go back and do. This is what everybody remembers. Everybody remember the Pythagorean theorem? Yeah, there you go. A squared plus b squared equals c squared. Okay, and the only catch is for this one is that c is your hypotenuse. A and B don't matter. A and B, you can switch those up. So A could be 5 and B could be 10, or A can be 10 and B could be 5. Those two don't matter. The only one that matters is your C value. That has to be the hypotenuse. Always has to be alongside. The A's and B's are interchangeable when you go through that part. Okay, so for that one, we'll just say that A is 10 and B is 5. So if we do A squared plus B squared equals C squared, that's 10 squared plus 5 squared equals, we don't know squared. Okay, 10 squared is 100. 5 squared is 25. Add those two together. So we got 125 equals y squared. Okay, does anybody remember how we get down to get the final answer from there? Just got square root, right? So if we've got y squared, we got to square root both sides. Okay, and first thing is always check it and see, because occasionally we get lucky and we square root it and we get a perfect number. In that case, we don't. So this is one you got to use your Finding Nemo exit buddy way to do that. All right, so what we're going to do, we're going to go over here, and we're going to take the 125. Most of the time, y'all say y'all like doing the factor tree. So we're going to break it down. So if we take 125 and break it down, that's 5 times 25. 5 is prime, so it's good. 25, you can make it 5 times 5. Both of those are prime. So if we take the square root of 125, that's 5 times 5 times 5. Okay, so here's where your exit buddies come in. There's your buddies. You got a pair of 5s, so that means that 5 gets out. That 5 doesn't have a buddy, so he stays on the inside. Okay, now, if they ask for radical form, you got to do that. If they ask for just a decimal number, of course, you can just do that. Just punch it in and square root it, and you got it. And I don't know, sometimes they'll let you do this answer. Sometimes they'll let you do a decimal answer. You just have to kind of read through and see, what they're going to have you do there. Everybody remember doing the Pythagorean theorem? I mean, most of the one, that's usually the one everybody kind of remembers doing that one. Everybody's always, oh yeah, a squared plus b squared equals c squared. Okay, and then the last thing we're going to do is there was 2 special triangles that you did when you were doing all this stuff, and hopefully you remember these. If you don't, we'll show it to you real quick. So here's basically where we got the unit circle thing from. Okay, so if we did special right triangles, you remember the 3069, or at least you remember talking about the 3069 triangle? At least ring a bell. Hopefully. Maybe. Maybe not. Okay. Okay, now, and here's basically what we're going to do for this one. Let's just pretend that triangle we've got here would be the same as that. Oh, look at it. That would be our 30, 60, 90 triangle we're looking at right here. So basically, think of this triangle here as this triangle right here. That this is our distance going across that basically, and that's really what this thing is. When we're doing these 30-degree angles and the 45 and the 60, that if we connected these together, this is basically where we're getting that 30, 60, 90 numbers from. We're coming from this thing. All right, and what we said yesterday when we were working on this thing, that this was always going to be 1. So if we kind of go back to that special triangle we're looking at here, you can actually go back and do the numbers and figure out what everything was going to be. And we'll do this. We'll set this up. This is our hypotenuse, which is our longest side. This is going to be our shortest side because it's opposite of the 30-degree angle. If you draw through the 60, this is going to be our medium side. So we got a short, medium, and long sides. Just like you've got a short, medium, and long angle, the sides match up the same way. Now, the one thing we said for this one is that this hypotenuse, the long side was going to be 1. And again, we're stealing this triangle that we would have drawn back here with the unit circle, that we knew this side over here was 1. All right. And we're going to show you how we could use, if we want to find this short side over here. So if we were finding this short side, again, we're not worried about the medium side. We just need to find the short side for a minute. This would be the opposite. Because we're using this 30-degree angle. This would be the opposite, and this would be the hypotenuse. And somebody may be saying, why using the 30? Well, if they give you 2 angles, you just have to pick one. So if they gave us a 30 and a 60, if we're trying to figure out what this side is, you just got to pick one of the 2. So I picked the 30. So this is the opposite side, and that's the hypotenuse. All right, so if we use opposite and hypotenuse, that's sine. We're trying to figure out what the opposite side is. We know the hypotenuse is 1. And if we punch in sine of 30, that tells us that's going to be a half. Or it's 0.5. So again, if we put that over 1, we do the cross products. X is still 0.5. But if you think about our numbers, that's going to be a half. We put it in fraction form. All right, now, here's the trick. Here's what they should have told you in geometry last year, and you may or may not remember this one. If you have the long side, to get back to the short side, all you have to do is divide it by 2. And that gets us the same thing. Oh, now think about back here when we're doing this one. We knew this was cosine, this was sine, right? We just found out that this answer right here was a half. Well, that's how we figured out this thing was going to be a half, by doing that part of it. Okay, and then to go from short to medium, you take this side, and then you multiply by square root of 3. So this becomes square root of 3 over 2. Okay, so what that means, and you don't have to write this down, I'll just kind of show you real quick, that if this side had been, again, don't write this down, just kind of get through this one. If this side had been 10, then this side would take 10 divided by 2. This side would have been 5. And then the medium side would have been 5 square root of 3. So anytime they give you the long side, all you do is take the long side and divide it by 2 to get your short side. And then to go from the short side to here, you just multiply by square root of 3. Okay, and that's how we got this stuff over here. We just didn't tell you that. We just wanted you to kind of go back and kind of memorize through those to get there, to get what you need. Okay, and then the other one that was the other special right triangle, I'll show you this one, and then we're done. Last one. 45, 45, 90. Okay, and thing for about 45, 45, 90, you still got your hypotenuse here. That if it's a 45, 45, 90, that means that these two sides here are the same. So if this is x, then that's going to be x. So these two sides are always the same. This is the one that will be, so the hypotenuse will be different from the other two. But these two sides will always be the same. They'll be, so if this is 8, this one's 8. Okay, and what they do, like for this one, we do like short, medium, long for this one. A lot of times for these, because these are the same size, that basically they say these things are, they call these legs. This is leg and this is a leg, because usually your legs are the same size. If you want something to be stable, then they need to be the same size. So they just call these legs, so they're basically equal length there. Okay, and this one has a shortcut too. That to go from the leg to the hypotenuse, so if they give you one of these sides over here, say the side's 8. If you need to go from the leg to the hypotenuse, you multiply by square root of 2. So if they tell you this side is 8, then the hypotenuse is going to be 8 square root of 2. Okay, and then to go from the hypotenuse to the leg, well, we're going to do the opposite. Instead of multiplying by 2, we're going to divide by square root of 2. Okay, now, and this is one, again, we're just going to make up a whole number on this. Let's say it was 10. Actually, hang on. Let's make it 7. All right, and this is where we did this one the other day. This is where we get to the shortcut. So this thing is going to be 7 divided by square root of 2. If y'all remember, we said if you were doing this thing, you cannot leave that square in the denominator. They don't like that. So this is where we're going to change this answer. We're going to move the square root of 2 from the bottom to the top. And on the bottom, you're going to leave just the 2 and leave the square root off. So we got to use that shortcut we did before. So if you divide by square root of 2, again, move the square root from the bottom to the top. On the bottom, take the square root off, so you've got your number there. Okay, now where that worked back here, just to kind of show you for this one, this would have been a 45, 45, 90 triangle here. And again, the one thing we know in this case is the hypotenuse is 1. So to get this number here and this number here, we took 1 and divided it by square root of 2. But then to rationalize that again, we took the square root of 2, moved it from the bottom to the top. And on the bottom, we took the square root off and just made it 2. So that's why this thing was square root of 2 over 2. If we know what this side is, then we know this side is going to be the same thing. So that's why they're both the same thing.